Good day, students. This is your teacher that the course we rounding up our lessons on aluminum extraction with this video. And at the end of this video, you should be able to state the physical, chemical properties as well as the uses of aluminium. And what is even more important, you should be able to state why you should be able to relate the properties of aluminium to its uses. That is what this video is designed to do. So we want to start from the physical properties of aluminium. Aluminium is a silvery white metal. It is malleable and ductile. Malleable means it can be beaten into sheets. Then it is ductile, it can be drawn into wire. It has high melting point of 660 degrees Celsius and it can conduct heat and electricity. Now we move to the chemical properties of aluminium. Number one, and one of the most important of properties of aluminium is when aluminium reacts with air. When you expose aluminium to air, take note of that language. When you expose aluminium to air, a thin adherent layer, that is a thin layer that adheres to the surface of the metal, that stick to the metal surface, is formed. That layer is aluminium oxide layer, but formed very thin. It will be formed on the surface of the metal. What this layer does is to prevent the internal metal from further reaction. So what I'm trying to explain to you is this. This is the aluminium metal that you expose to air. This aluminum metal is exposed to air. You can see oxygen from the air. Immediately you expose it to air, a thin layer of aluminium oxide is formed. This thin layer is aluminium oxide layer. So not all the aluminium will react with oxygen. Only the surface atoms will react with oxygen and form a very thin layer. This thin layer will protect the other atoms from reaction. So when that thin layer is formed, the aluminum will no longer react at normal temperature and pressure, at normal condition. And that is why we say that aluminium metal does not corrode. That is, it doesn't undergo corrosion. It will not corrode completely. It will not get degraded completely, because once it is exposed to air, the oxide layer will be formed and protect the metal from further reaction. You can see the reaction here at the bottom of the screen. However, when you heat this aluminium oxide, and when you heat this aluminium metal to a very high temperature of 800 degrees Celsius, the remaining aluminium metal will react with oxygen and nitrogen in the air at that temperature to form aluminium oxide and aluminium nitride. This equation, aluminium oxide will react with more oxygen, that is, at higher temperature. This reaction will occur to form aluminium oxide, while it will also react with the nitrogen inside air to form aluminium nitride. Aluminium nitride is ALN because aluminum is +3, nitride is -3, so it will cancel out and give you ALN. So that's why we say that aluminum does not corrode, because a thin layer of oxide is formed which protect the metal from further reaction. Now, apart from this, aluminum does not react with HNO3 at any concentration. Remember that HNO3 is an oxidizing acid, so it doesn't react with HNO3 at all because of the formation of that protective layer of aluminum oxide. That layer will prevent aluminum from reacting with acid, reacting with air, or reacting with base at all. So that layer protects it. That's why it's not going to react with HNO3, but it can react with hydrochloric acid and conc H2SO4. But in this case, HNO3 doesn't react because it's an oxidizing acid. That is why you can transport HNO3, that is, you can transport trans 5 acid inside the container that is made of aluminum, because you expect that there will not be any reaction between the aluminum and the trans 5 acid. So that's why you normally use the container to transport that acid. Now, aluminum reacts with alkali. Remember that the aluminum is an amphoteric metal, so it can react with acid and bases. So it can react with alkali to form aluminatory salts of the metal inside the alkali. It can react with sodium hydroxide to form sodium tetrahydrozoaluminate 3. It can also react with potassium to form potassium tetrahydrozoaluminate 3. So aluminum reacts with alkali, caustic alkali, and this is the reaction here on the screen. Take note of this reaction, is very, very important. Take note of the reaction. You might be asked in exam to write the reaction of aluminium oxide, with sodium hydroxide or potassium hydroxide, anyone. So aluminium reacts with sodium hydroxide. In the presence of water, there must always be water, but because it takes place in presence of water, to give you sodium tetrahydroxoaluminate 3 plus hydrogen gas. Hydrogen gas is liberated. Take note of that. Very, very important. So because sodium hydroxide can react with aluminium, that's why you don't wash aluminium vessel. You don't clean aluminium vessel with washing soda, because washing soda can dissolve in water to form sodium hydroxide, which will in turn react with the aluminium and dissolve it. So you don't wash aluminium vessel with washing soda because of the danger of reaction with sodium hydroxide. So those are the important reactions of aluminium. If you need more, you can check your textbook on that. So finally, before we end this video, we'll talk about the uses of aluminium, and I'll talk about number 1. Aluminum is used for making cooking utensils. You can see on the screen cooking utensils. And most of the stuffs in your kitchen are made of aluminium. And what is the reason why we use aluminium for this purpose? Because aluminium is cheap and it is light and is a good conductor of electricity. Number 2, aluminum is used for making overhead cables. You can see overhead cables. You can use aluminum for making those overhead cables. And what is the reason? Because aluminum is not heavy, it's light, it's also ductile, can be drawn into wire, and has good electrical conductivity. Another function of aluminium, use of aluminium, is that aluminum alloys are used to make the bodies of cars as well as the aeroplane. If you want to make an aeroplane, you need something that is not heavy. You need something that is light because it must fly. So aluminum alloys, they are light, they are strong, and they resist corrosion. So that is why you use them. You use aluminum for that particular purpose. Before we round up, second to the last, aluminum is also used for making cans of drinks. can see all the Coca-Cola, all the Pepsi and everything, they are made with aluminum vessel because aluminum is light, is malleable, can be beaten into thin sheets, and is resistant to corrosion. Then aluminum is used for making packaging materials for food. You have seen aluminum foils in parties before, used to pack shawarma, used to pack the some of you in your house spots, your house eat shawarma. So they use aluminum foil to pack it. The reason is because aluminum is light and does not corrode, so it will not react with the acid in the food or in the drinks. That's why aluminum is used for packaging food. Apart from that, it can be used as a roofing sheet because it's also not corrosive. It can be used as roofing sheets. So take a look at this evaluation question. We are asked to give reasons why the following is observed. Why the followings are observed. Number one, why aluminum does not corrode. Reason, because it forms a thin layer of protective oxide that prevent the metal from further attack. Then number two, why bauxite is purified before aluminum is extracted. We have done that in our previous video to remove impurities and get high yield of aluminum. Number three, why aluminum is extracted by electrolysis, because it's reactive. Then why is aluminum used for packaging food and drinks? Because aluminum is light, does not react with acid in the dry. It doesn't corrode, and is also flexible. So those are the reasons why aluminum is used for packaging foods and drinks. It's also malleable, you know that. So this will be the end of our discussion on aluminum and its extraction. So God bless you. If you have any question, you can comment below. I will answer your question. God bless you. Thank you.